questions basically introduce the idea to reinforce what it means to be similar. And that is that I can map one shape onto another using only similarity transformations, rotations, reflections, dilations, and rotations. And so I have two shapes here, two triangles, OFG and OTM. And if I want to establish that they are similar to each other, then what I want to do is try to map one onto the other. One thing that would be what's important to tell you as well is read carefully who's mapping onto who, because the order then would matter. And in my case, I'm going to map the pink triangle onto the clear one here. So I have a couple of options. I could dilate it down first, then rotate it. I could rotate it, then dilate it. I think I'm going to dilate it first. So I'm going to dilate my triangle. And maybe I should think about how big. A half would be, let's see, so 6 and 3 would be 3 and 1.5. Now I notice over here none of my points are 3 and 1.5 away. So, and that looks smaller than a half. So I'm gonna actually try a third here and dilate it by a third, and there, that looks good. And I'm going to just maybe change the color of this just a little bit so maybe it stands out a bit. So there we go. The first would be a description of a dilation about O, the origin, of a scale factor of 1/3. Now I'm going to take those points, and I'm going to rotate them 90 degrees about O again. And so I'm going to do a rotation of 90 degrees, and there it lands right into the spot. I'll just change the color so you can see what took place. So that would be two transformations. First, a dilation of a scale factor of 1/3, and then second, a rotation of 90 degrees about O would map one onto the other.